Hello everyone and welcome to this new course about the IPM suite of PETEX. In this first video we are going to discuss about the IPM suite, a very brief introduction to the suite, and also the basics and application of the most important programs of the suite. Okay? So IPM stands for Integrated Production Management. This is a suite of software that we can use for modeling oil and gas production systems. Okay, oil and gas production system includes wells, injectors and producers, reservoirs, also a network of surface facilities. So as we can see, we're modeling the entire system, the entire production system. The suite includes many programs. Some of them are PBTP, Prosper, MBAL, GAP, Reveal, Resolve, and so on. In this course, we are going to learn about Prosper for modeling wells, MBAL for modeling reservoir, and GAP for integrating the wells modeling Prosper and the reservoir modeling MBAL with the networks of surface facility. The suite is designed for modeling oil and or gas production systems and also water and gas injection wells. Okay, so we can model here reservoirs in primary and secondary recovery. Nice. When the wells and reservoir and surface facility have been modeled, sometimes including history matching, because if we have production history, we can match the production in MBAL, the total system can be optimized. What does optimize mean? Okay, we may have several scenarios, many different scenarios, and for each scenario we can get one production profile. The optimum one is the profile that maximizes the hydrocarbon production, minimizing our cost. As reservoir engineer, we have to provide to the economy. We have to provide to them a production profile, and then they will convert the production profile into a cash flow. So in that way, we can find out if our project is profitable or not. Okay, and we can rank different projects and find out which one is the best one for the company. So the first step is providing the profile, and we can provide many profiles, many different profiles based on different scenarios obtained with this software. This integrated approach is integrated because we are integrating reservoirs, wells, also surface facilities, allows the engineer to obtain the optimum scenario, where hydrocarbon production is maximum, despite the restriction of the system itself, because we have restrictions in the reservoir, in the flow within the reservoir. We have restrictions in the well and also restrictions in the surface facilities. So we have to consider all these restrictions during our modeling. Okay. In this course, we are going to study the fundamental of three of the applications that the IPM suite has. These are Prosper, as we say, for modeling wells, MBAL for modeling reservoir, and GAP for the integration of wells and reservoir with surface facilities. Prosper is the first software we are going to learn. It stands for Production System Performance. This is a software developed for nodal analysis of multi-phase flows in horizontal and vertical pipes. As a reservoir engineer, we use Prosper most of the time for vertical pipe because we want to get the performance of the wells and we can to also export this performance, this curve, performance curve for the well, vertical flow, to the simulator. So most of the time, as a reservoir engineer, that's what we do. We use the prospect for finding out how the well produce the fluid, water, oil, and gas. However, in this course, we are going to learn, we are going to make a couple of models with horizontal pipe too. Okay? With this software, we can obtain the IPR curve. IPR stands for inflow performance relationship. It's the curve that somehow gets information about how the reservoir allows the flow and how much rate we are going to get depending on drawdown. Also, we can get the VLP curve. The VLP stands for vertical lift performance. They are also known as a tubing performance relationship or vertical performance relationship curve. In this curve, I'm going to refer to them as a VLP curve. Okay? This is the curve that this is what we could call the demand curve. I mean, it's the curve that give us information about how much the well can produce. The intersection between the IPR curve, which is the fluid that the reservoir can offer, and the VLP, which is the curve of how much fluid the well can get, the intersection between them is the rate, or the rate on which our well is going to flow. Okay? We can make production and injection models with this software, which is, as we discussed earlier, is very good because we can model not only production but also injector wells. This well can be in natural flow or can be in any artificial lift. I mean, we're talking about gas lift, ESP, PCP, hydraulic pumps, rod pumps. In this course, we are going to learn how to create a model for wells in natural flow and also wells in artificial lift, in gas lift, in ESP, using PCPs, using HPs, using rod pumps. So we are going to learn how to get any model with any artificial lift and also natural flow in this course. The well can also have some control completion. I mean, we're talking about gravel packs. We're talking about frac packs, slot liners, and so on. In this case, we are going to learn most of these sunk control completion. We are going to learn how to model them. So this is very important because if you are working in a company with wells producing with sunk control completion, you will be able to reproduce them in the simulator, in this software. Our wells can also be vertical, they could be horizontal, they could be slanted, and even multilateral. We are going to learn how to model each of them. We will start with vertical wells, then we will increase the difficulty modeling slanted wells, also horizontals, and finally we will have one video about modeling multilateral wells. Right? For learning Prosper, we will need about 40 videos of more or less 20 minutes each. I mean, these videos are going to increase in difficulty with time, and they will be available in the YouTube channel. No? So if you have the software in your company, or you have the software in your computer, you will be able to follow every single exercise, because the course is going to be very practical. That's the idea. The idea is learning how to use the software. So the course is going to be very practical. And I will share with you the data in the comments of each video every time. No, so you will have the data for loading the data in the model in the software. MBAL stands for material balance. This is a software designed for analytical studies of reservoir. This application uses different tools, but the three most important ones are material balance, cold bed methane, and also tight reservoir. Because we are going to need only about 5 videos of 20 minutes more or less for learning MBAL. We will learn mainly the material balance tool. However, we will make a video for cold bed methane and also for tight reservoir. In these videos, we are going to include history matching because that's very important. And also, we will learn how to make prediction, which means how to get production profile using only MBAL. But you have to be aware that the production profiles obtained with MBAL, they don't consider the bottlenecks of surface facilities. So most of the time, the production profile obtained with MBAL are very optimistic. No? So we have to be very careful with this profile. Finally, we will study GAP. We will need about 10 tutorials, 10 videos for learning this application. GAP stands for General Allocation Package. This is a software designed for in the integration of the reservoir and well, the reservoir model with MBAL, the well model with PROSPA. Then we can, after finish the model of the well and the model of the reservoir, we can integrate those models with the surface facility. GAP can create graphical networks to the integration of surface and subsurface components. So it's very friendly, it's a very friendly user software, and it's one of my favorite ones. It's very, very powerful, and the production profiles obtained with this software, they do consider the bottlenecks of the surface facilities, not also the reservoir and the wells bottlenecks, but also in the surface facility. So these profiles are maybe the best one you have to provide, the best one you can provide to the economy. Once the software has integrated the surface and subsurface components, the system can be optimized. So in that way, we can get the optimum profile. We will learn how to get the optimum profile based on different scenarios. Okay? As we say, we will do that in 20 videos more or less. If you need more information about this software, what I can recommend to you is you could go to the website of Petroleum Expert. They have a website, it's petex.com. Okay? In the website, you will get information about products, services, career, if you want to work with them, the company, how to contact them. In product, if you click products, you will go to the product website, and you will find out that they have 3 different suites. We are interested in the first one, in the IPM suite. Okay, if you click in the IPM suite, you will find information about Resolve, GAP, GAP Transient, PROSPA, MBAL, Reveal, PBTP, OpenServer, and that which are the software that integrates the suite. Okay. In our case, we will learn about PROSPER, about MBAL, and about GAP. After finishing the videos of PROSPER, MBAL, and GAP, I will maybe make some videos about PVTP, which is the software for thermodynamics fluid characterization. It is software that we use more or less on daily basis for validating PVTs that come from the laboratory. Also, we can use it for getting synthetic PVTs and so on. No? So it's very powerful, and maybe we will have some videos about PVTP. Here you can get additional information for each of them. Okay, just as a final words, thank you so much for watching the video. If you have any comment or any question, please let me know. You have not only my website in LinkedIn, but also you can comment here in English. Okay? Thank you so much for watching the video, and I hope I will see you in the next video, where we will start with Prosper modeling a vertical well in natural flow. Thank you so much. Take care.